All right, for this video, we're going to run through some specific numerical examples of dealing with the two special right triangles. So, as a quick reminder, the relationship in a 45-45-90 right triangle is whatever one of the legs is, the other leg is the same. And whatever these two guys are, you're multiplying by root 2 to get the hypotenuse. Or going in reverse, if you know the hypotenuse, you're dividing by root 2 to get these two guys. All right, your other special right triangle, the 30, 60, 90. The key side we like to know is the smallest side, which is the side across from the 30. Whatever that is, you're doubling it to get the hypotenuse. Whatever that is, you're multiplying it by root 3 to get the hypotenuse. If the number that you start with is the hypotenuse, and you want to cut it in half to get the shortest side, then multiply by root 3. If the number that you know to start with is this side, the side across from the 60, whatever that is, you divide by root 3 to get the shortest side, and then double. All right, running through some 30, 60, 90 examples. They label this 30, they label that 60. They don't have to label this because if they give you 2 of the 3, the third angle must be whatever the 180 thing is, in this case a 90. All right, the number that they're giving us to start with here is the hypotenuse, the longest side, which is across from the right angle. Whatever that is, we cut it in half to get the shortest side, or the side across from the 30. And whatever that is, we multiply it by root 3 to get the middle side. All right, moving to the right, the side that they're giving us to start with is the smallest side, the side across from the 30. We double that to get the hypotenuse, multiply it by root 3 in order to get the middle side. Now, both of these examples have the radical root 3 in what I call the happy place, the spot where it lines up nice and clean, where we expect to see it working off of the general case here. You don't always have a root 3 in that happy place. So, for example, with this one down here, the side that they're giving us is the one across from the 60. That doesn't have a root 3 in it. Anytime you know the side that's across from the 60, we want to go to the shortest side by dividing by root 3. If you're multiplying by root 3 to go in this direction, from here to here, it means you divide by root 3 to go in the other direction. So for this particular problem, when you divide by root 3, it gets a little bit messier. You really shouldn't be leaving final answers with radicals in the denominator, so that gets rationalized to 20 root 3 over 3. Okay, now that we know this middle, the shortest side rather, the one across from the 30, whatever that is, you double it to get the hypotenuse. And one more example where the radical is not in the happy place. It is up here as the hypotenuse, and it's a root 6. Well, if you know the shortest side across from the 30, you double it to get the hypotenuse. If you know the hypotenuse, you cut it in half to get the shortest side. So we have to cut root 6 in half. That gives us the shortest side, or the side across from the 30. Then whatever that is, we have to multiply by root 3 to get the middle side. Root 18, a little scrap work on the side to simplify that. It's 3 root 2. So we get 3 root 2 over 2 to be the length of the middle side, or the one across from the 60 for that particular triangle. So for this particular set of examples right here, we had 2 with the root 3 in the happy place, 2 with the root 3 not necessarily in the happy place. We have starting with the hypotenuse with these two guys, starting with the shortest side there, starting with the middle side there. So that's a little bit of everything in terms of what can happen with a simple numerical problem like this. So one of the things you're expected to be able to do in this class is, if it's a known 30, 60, 90 triangle, if you're given any one of the 3 sides, you need to be able to get the exact value of the other 2 sides. All right, the 45, 45, 90 is a little bit easier to deal with. We're not going to do all 8 of these problems. We'll just do a sampling of them. So for the format here, they're giving us one picture and then a bunch of different scenarios. So for question number 1, they're telling us A is 5. Well, that's one of the 2 legs. Well, if one of the legs is 5, the other leg has to be 5. And then the relationship is whatever the legs are, you're multiplying by root 2 to get the hypotenuse. So there's an example of nice, easy one. The root 2 is in a happy place. Okay, number 2 is basically the same problem. I'm going to skip to number 3. Here they're telling us that C is 11 root 2. So if this is 11 root 2, to get from the hypotenuse to the 2 legs in the 45, 45, 90, you're dividing by root 2. If it's multiplying by root 2 in this direction, it's dividing by root 2 to reverse it. So those 2 guys are going to be 11. All right, now we'll do a couple of examples where we have radicals that aren't necessarily in a happy place. So for number 4, they're telling us side A is root 10. Well, whatever this is, that has to be the same because those are the 2 legs of that right triangle, that 45, 45, 90 right triangle. And then whatever these are, we're multiplying it by root 2 to get the hypotenuse. So root 10 times root 2 is root 20, and that simplifies down to 2 root 5. All right, number 5, right below it, they're telling us that side B, which is one of the 2 legs, is 8 root 2. The other leg has to be 8 root 2. And then to get from these guys to the hypotenuse, we multiply by root 2. So 8 root 2 times root 2 is 8 times 2, which is 16. All right, we'll do one more of these. What if the hypotenuse is a non-radical number? For example, here 20. Well, whatever that is, whether it's a whole number or radical, whether that radical is root 2 or not, you're going from there to there by dividing by root 2. So do this scrap work up here. 20 over root 2. Rationalize that. And that simplifies to 10 root 2. And whenever one leg is, the other one is the same. All right, there's really nothing of note that's worth going over as far as additional examples. With the rest of these guys, it's following the same rules we've already emphasized. All right, next thing we're going to do is sometimes you get a composition of triangles here. So, for example, with this one here, this triangle on the left is a 45, 45, 90. This triangle on the right is a 36, 90. So we have 2 triangles that share that side AC in common. So they're going to give us one length from this composite figure and asking us to find a bunch of others. So for example here, AB is this length right here is a 10. So that's part of the 30, 60, 90. So I'm going to ignore that stuff that's over here and just concentrate on the right triangle on the right. If we know the hypotenuse is 10, we're cutting it in half to get the smallest side, the side across from 30, and then we're multiplying that by root 3 to get that side. So AC, 5, BC is 5 root 3. Okay, now I'm going to ignore this and concentrate just on the 45, 45, 90 on the right. That 5 is one of the 2 legs. So if that's 5, the other leg is 5. And then we multiply that by root 2 to get the hypotenuse. So AD is 5 root 2. CD is 5. All right, that's a little bit messy to erase and go over, so I'm going to do number 2 on a clean sheet. Actually, 2 is almost the exact same as 1. I'm not even going to bother to do that. It's the same set of numbers. You're starting with a 7. The one that's a little bit more interesting is I'm going to skip to number 3. All right, for number 3, they're telling us that AD is 6. All right, so that's the hypotenuse of the 45, 45, 90 that's on the left. So if we know the hypotenuse of a 45, 45, 90, we're dividing by root 2 to get these two guys. So 6 over root 2. Rationalize that. So it's 3 root 2. So filling in our table, CD is 3 root 2. AC is 3 root 2. All right, now I'm going to go to the triangle that's on the right. That is the side across from the 30, so that's the shortest side. We're multiplying that by 2, or we're doubling it to get the hypotenuse. And then we're taking that guy and multiplying it by root 3 to get the middle side, or the side that's across from the 60. So 3 root 2 times root 3 is 6 root 6. So filling in the table, BC, that is the, that's a mistake. I apologize. It's 3 root 6. Good catch by me. The 3 times a 1 is a 3. Root 2, root 3 is 6. 3 root 6. And then AB was that hypotenuse, which is 6 root 2. All right, so those are the typical types of questions that you need to know for dealing with numerical problems that involve finding missing sides of our two special right triangles. Okay, the worksheet that you need to do for practice for these guys, just a quick overview of what's going on. So for numbers 1 through 8, it's just a single special right triangle. They're giving you one of the 3 lengths, and they're asking you to find the other 2 sides. Okay, 9, 10, 11, 12 on the bottom is some composition of figures that involve 2 special right triangles. So you have to work your way around the picture to get to the one particular measurement they're asking you for. So for example, with number 9, you'd start with the 45, 45, 90 on the left. You'd have to work your way to get that side and then finish up with the 45, 45, 90 on the right. Okay, 13 through 16 on the other page are just like 9 through 12 on the first side. All right, now here's something to be careful with. Just because a triangle looks like it's a 30, 60, 90 or 45, 45, 90, you can't assume that it is. So what this worksheet finishes up with are 6 triangles. It doesn't say in the instructions anything about being 30, 60, 90s or 45, 45, 90s. There are no labeling of any angles on any of those pictures. So with these guys here, you can't assume any of them are 30, 60, 90 or 45, 45, 90. Maybe they are, but it's kind of by accident. It's not on purpose. So what we were dealing with here are 3 right triangles. They happen to be giving us 2 of the 3 sides. So the thing you're probably going to want to use here is the Pythagorean theorem. So this goes back to the worksheet from the previous day. Those are just straight up Pythagorean theorem, a squared plus b squared equals c squared problems. You're not using 30, 60, 90, 45, 45, 90 for these guys. Okay, the other option that is available to you with any of this triangle stuff we talked about today is you could use SOHCAHTOA trig. SOHCAHTOA trig is a valid tool for everything that we've talked about. Technically, you don't know that. That's what we're going to start off next week with, is the introduction to trigonometry. After you learn both, it's your call in terms of what strategy you want to be using. But for these types of problems, the stuff that we talked about today is the better option even after you know right triangle trig. But for now, it's the only option based on what we know for this particular class. All right, this worksheet does not need to be submitted As I had said in one of our opening videos, not every classwork homework assignment is going to be submitted or collected however it is that you're turning it in. This one here, practice it. The answer key is going to be posted. Check your answers. You're responsible for this come the first test that we're going to have. And when we get there, we'll talk about the details.